Welcome to the deep dive. Today, we're looking at something that could really change the game in blockchain. Boundless from RISC Zero.
That's right.
Imagine blockchains without their current compute limits, like
Yeah.
truly unlimited power. That's the promise.
Exactly. Boundless is essentially a verifiable compute layer. Think of it as a way to add a turbocharger to existing blockchains.
So you do the heavy lifting, the complex calculations off the main chain.
Precisely. But, and this is the crucial part, you get a cryptographic proof back proving the calculation was done correctly, so you keep the trust.
Okay, so it's combining that off-chain power with on-chain security.
So today we'll unpack Boundless, how it works, the tech behind it, what's new, and what it could mean for DeFi, gaming, AI, you name it.
And how it compares to other ways people are trying to scale blockchains.
Right, and importantly, it's not another blockchain.
That's a key point.
Yeah.
It works with existing chains.
Yes. The core idea is actually pretty elegant. Run your big programs off-chain, where compute is cheaper and faster. Then you just post a small zero-knowledge proof to a smart contract on-chain.
And that proof basically says, yep, this program ran correctly.
Exactly. The blockchain verifies the proof, which is super fast, instead of rerunning the whole complex program. Saves everyone time and money.
And that RISC Zero zkVM, that's the engine for running these off-chain programs and getting the proof.
It is. It's a virtual machine based on the RISC V standard, open source, which is great. It can run pretty much arbitrary code and generate a specific type of proof called a zk-STARK.
zk-STARKs. Those are the ones that don't need that trusted setup phase.
Right. No trusted setup needed, which is a big security plus. You can think of the zkVM almost like a simulated CPU, but one that produces this cryptographic receipt, the zkP, for everything it computes.
So if I'm a developer, what's my workflow look like?
Well, you'd write your, let's say, complex DeFi logic to run inside the zkVM off-chain. You run it, you get back the result, and this proof, this receipt.
Okay.
Then you send that proof to your smart contract on whatever blockchain you're using. That contract uses RISC Zero's verification code to check the proof. If it checks out, the contract trusts the result.
So Boundless acts like a co-processor for your smart contract. You offload the hard stuff.
That's a great way to put it, a co-processor. You keep the main chain lean and mean, just handling verification and settlement.
Which is totally different from how blockchains usually work. Normally, every node runs every single line of code, doesn't it?
Every single node. It's massively redundant. Like asking everyone in a city to manually calculate pi to 1,000,000 decimal places just to agree on the result.
Yeah, not very efficient. That's the scaling problem right there.
Exactly. But with Boundless, only the prover, the one running the zkVM, does the heavy computation. Everyone else just quickly verifies that cryptographic receipt, much, much lighter.
Okay, maybe we can break down the differences a bit more clearly, like side by side.
Good idea. So execution of the logic, traditional, on-chain, every node, boundless, off-chain, just the prover on the zkVM.
Verification.
Traditional, it's implicit. You trust it because everyone else ran it too. That's consensus. Boundless, explicit verification using that zk proof. Mathematical certainty.
Throughput and scaling. Seems like a big one.
Huge. Traditional is limited by block space, gas limits, network speed. Boundless. Potentially orders of magnitude larger throughput, much lower cost for complex stuff because the heavy work is off-chain.
And for developers, the experience must change.
Big time. Traditionally, you're often stuck with Solidity or similar languages, always watching gas costs, simplifying logic. With Boundless, you could use, say, Rust or C++ in the zkVM and worry less about gas for the execution itself.
What about the security foundation?
Traditional security is based on that network consensus, 51% attacks, etc. Boundless relies on the cryptography of zk-STARKs. If the math holds, it's secure. No trusted setup helps there too. It inherits security from the base chain for settlement, of course.
And how things connect. Composability.
On-chain composability is usually easy within one chain, but cross-chain is notoriously hard. Boundless aims for global composability. Since the proof can be verified anywhere there's a compatible verifier, one off-chain program could serve many chains.
It's like that weather analogy you mentioned earlier, right? One supercomputer does the forecast, sends out a verified report.
Exactly that, instead of every town doing their own shaky forecast. Okay, so let's dig into the specific innovations that Boundless brings.
First one, unlimited execution. Sounds ambitious.
It really is. Because the computation happens off-chain, you're not constrained by block gas limits in the same way. You can run really complex algorithms, process huge data sets, things that are just impossible on-chain today.
So basically removing a major bottleneck for developers.
Totally. It opens up design space that was previously closed off. Think of it like suddenly having infinite RAM for certain tasks.
Next, verifiable compute. We touched on this, but it's core.
Absolutely fundamental. The ZK proof provides that mathematical guarantee. The blockchain doesn't need to trust who did the computation, just that the proof is valid. Trust through math, like a notarized document for computation.
Then there's off-chain processing and on-demand scaling.
Right, because the work is off chain, you can scale by just adding more provers, more compute power when needed. If there's high demand, spin up more machines. The blockchain only sees the small proofs, so it doesn't get congested. It's like elastic cloud computing, but for verifiable tasks feeding into blockchains, and it's generally cheaper.
Global composability. This sounds like it could connect different blockchain ecosystems.
That's the goal. A single off chain program using Boundless could potentially interact with or provide verified results to multiple different chains Ethereum, Solana, others, as long as they can verify the RISC Zero proofs. It acts as connective tissue.
And it's not tied to one specific chain, the chain-agnostic design.
Correct, it's neutral. The proofs generated by the RISC Zero zkVM, because it compiles to RISC-V, can theoretically be verified any way that supports the verifier logic. RISC-V is becoming a bit of a universal standard, which helps.
And finally, uncompromising security. How does that work?
Well, firstly, ZK Starks mean no trusted setup vulnerability. The security relies on a well-understood cryptography. A malicious prover simply cannot create a valid proof for a wrong answer. Plus, it inherits the security of the underlying blockchain for the final settlement step. And these proofs are designed to be verified quickly by anyone running a node.
Okay, so these features combined, they must enable some pretty cool applications that maybe weren't feasible before.
Oh, definitely. Let's talk about DeFi first. People are talking about getting CX performance with DEX trust.
So fast trades like a centralized exchange, but still decentralized and verifiable.
Exactly. Imagine complex order book matching or aggregating liquidity across 10 different chains, all happening off-chain with proofs. You could build DXs with a much better user experience. Think complex derivatives, cross-chain lending, things that are clunky or impossible now.
What about gaming? Blockchain gaming often feels limited.
Yeah, because complex game logic is expensive on chain. With Boundless, you could run sophisticated game engines off chain. Only critical state changes, like, say, the result of a player versus player battle or loot drops, get proven on chain.
So you could have provably fair complex games, like prove the card shuffle in poker was truly random.
Precisely that kind of thing, or even integrate verifiable data from Web2 APIs into the game logic.
Identity and privacy are huge topics too.
Huge. Boundless enables your ID, proven but private. Imagine having a ZK proof that verifies you're over 18 based on your official ID, but without revealing your actual birthday or name on chain.
Wow, okay. That could be used for KYC, civil resistance.
Definitely. Privacy-preserving credentials, selective disclosure. RISC Zero actually built a demo called Bonsai Pay, showing login with Google, proven via ZK to Ethereum. Super smooth onboarding potential.
Connecting Web 2 identity to Web 3 seamlessly.
Yeah.
What about AI? That's everywhere now.
Verifiable AI on-chain. This is pretty mind-bending. You could run an AI model off-chain, maybe analyzing images, making a prediction, and generate a ZK proof that the specific model ran correctly on the given input.
So you could trust an AI's output on-chain, like
Yeah.
for insurance claims based on satellite imagery.
Exactly. Or verifiable chatbots, provably unbiased algorithms, maybe even marketplaces for AI models where you pay for results with proof.
And cross-chain stuff. Interoperability is still a big hurdle.
Boundless could really help here, acting as a sort of one compute to rule them all for cross-chain actions. You could orchestrate complex transactions across multiple chains, verify asset states on one chain for use on another, simplify building cross-chain protocols significantly.
It also sounds like it bridges Web 2 and Web 3 better.
Yeah, connecting Web 2 data and services to Web 3, verifiably. You could fetch data from a standard web API, like weather data, stock prices, run some logic on it off-chain, and provide a proof to a smart contract that the data was fetched correctly and the logic ran as intended.
So smart contracts could reliably use real-world data.
With cryptographic guarantees, yes. Think Oracle solutions, but potentially much more powerful and verifiable for complex off-chain processing of that data.
And for just raw, heavy computation or big data tasks.
Big data, small chain footprint. Analyze large data sets off-chain, run complex simulations, statistical analysis, then just post the verified result on-chain. Decentralized analytics, complex DAO governance based on off-chain metrics. Lots of possibilities.
It's impressive. And you're saying people are actually building this stuff now. It's not just theory.
The building blocks are there, and early projects are definitely emerging. It's moving fast.
Okay, maybe let's revisit those analogies quickly just to lock it in. The homework one.
Right. Homework and the answer key. One person does the hard math problem, the prover. Everyone else just checks the teacher's stamped answer key, the ZK proof.
Supercomputer and the receipt.
Yep. Big supercomputer, off-chain zkVM, does the work, gives a tiny verifiable receipt, the proof, to the simple calculator, the blockchain.
Global Lego blocks for composability.
Build something complex using pieces from any set, any chain, then show the verified model or blueprint to everyone.
Teleportation versus road traffic for speed.
Instead of slow, congested on-chain execution for complex things, you sort of teleport the verified result using the proof.
And the video game highlight reel.
Yeah, blockchain doesn't watch the whole game, execute everything, just the verified highlights, proof, and key outcomes.
Okay, great. Now let's shift focus a bit to the Boundless protocol itself. How is this all organized?
So the Boundless protocol is set up as a decentralized marketplace. Think of it as a system to connect people who need verifiable compute requesters with people who have the hardware to provide it, provers, often running GPUs.
Like in exchange for ZK proofs.
Sort of, yeah. Provers compete for jobs, either in a real-time spot market or through longer-term service agreements. They get paid only after their proof is successfully verified on-chain.
What are the key ideas underpinning this market?
Two main ones. First, proof of verifiable work. This is a way to measure how much computation went into a proof resisting spam and fraud, and it's used to reward provers with the native token ZKC.
Okay, proof of verifiable work. Got it.
Second, the financialization of compute, using economics tokens, incentives, markets to make sure there's a reliable and efficient way for requesters and provers to find each other and transact. Boundless is the practical system built on these ideas.
Treating verifiable compute like a commodity you can trade.
Exactly. Because ZK proofs give you this objective mathematical truth about computation, it's perfect for trustless trading. Proof of verifiable work acts like a trustless meter for how much work was done.
How does the spot market actually work? You mentioned an auction.
It uses a reverse Dutch auction. The requester posts a job with a starting price that increases over time. The first prover to accept the job at the current price gets it.
Why that way? Price increasing.
Its fast ends on the first bid. It's relatively simple to implement on-chain, and it tends to find a pretty efficient price, usually the lowest a prover is willing to accept quickly.
So if I need a proof, what do I put in my request?
You'd specify what kind of ZKP you need, any input data or parameters, a timestamp for the auction start, that increasing price function, say in ETH or USDC, maybe require a bond from the prover, and set a deadline.
And where do I post this request?
You can post it on-chain to the main Boundless Marketplace contract, or potentially share it through other off-chain channels, but the final settlement and proof verification happens via the on-chain contract.
And the provers?
Yeah.
How do they choose?
They'll look at the proof complexity, the deadline, how busy their own machines are, the current price versus their costs, what other jobs are available, who else might bid, standard market calculations.
Can they reserve a job?
Yes, they can choose to immediately fulfill it, or they can lock it by putting up a stake. Locking gives them exclusive rights to submit the proof before the deadline, though the requester can choose to disallow locking if they prefer.
How does the prover get paid?
They get the price that was active when they locked or fulfilled the request, minus a small market fee. That fee goes into the protocol's treasury, or vault. Provers can also batch proofs together to save on gas when submitting.
What if a prover locks a job but then flakes? Misses the deadline.
Their stake is slashed, they lose it. The request might then go into a retry mode, maybe offering some of that slashed stake as an extra incentive for another prover. Or the request just expires. Requesters can use strategies like short deadlines and high fixed prices if they need speed.
And the idea is that anyone can become a prover, right, to keep it decentralized.
Exactly. Using commodity hardware, open source software, the goal is low barriers to entry. That encourages competition, keeps prices down, and ensures reliability. What they call compute liquidity.
Okay, tell us about the token, ZKCC. What role does it play?
So ZKC has a capped total supply. New tokens are minted at a variable rate, controlled by token holders through governance, and these new tokens reward provers via that proof of verifiable work system.
So it incentivizes proving.
Yes. Plus, holding ZKC lets you generate points. These aren't transferable tokens, but they give you a claim on the market fees collected. You can also stake ZKC in the market or in service agreements. Reward frequency is also governed.
How exactly does proof of verifiable work distribute those rewards?
Boundless tracks the total fees collected and the total compute cycles proven across the whole market, and also per prover. A prover gets rewarded with new ZKC proportional to their contribution. It's based on whichever is smaller, their share of total fees or their share of total cycles.
Whichever is smaller, why?
It prevents gaming the system, like generating lots of easy proofs just for cycle count or only taking high fee jobs. It balances incentives. Any minted tokens not distributed this way are burned.
And this relies on that RISC Zero zkVM feature again.
Yes. Crucially, the RISC Zero zkVM lets provers securely embed metadata inside the proof itself, saying how many compute cycles it took. It also includes a nonce, like a unique ID, so a proof can't be submitted for rewards twice.
Clever. You mentioned the vault where fees go. How does that work?
Right. A small take rate fee from every fulfilled request goes into the vault on each chain Boundless is deployed on. Each vault holds locked ZKC. Token holders can lock their ZKC in the vault to earn those non transferable points over time.
And the points let you claim the fees.
Exactly. You burn your points to withdraw a proportional share of the accumulated fees, ETH, USDC, whatever was used for payment, and/or unlock your original ZKC. Vault tokens can also be used for staking in agreements or locking requests while still earning points.
Okay, one more piece. Verifiable service agreements. These aren't the spot market.
No, these are like longer term contracts, binding agreements between a specific requester and prover for future compute with pre agreed terms, price per cycle, duration, volume, etc.
So more predictable pricing and supply.
Exactly. They're implemented as smart contracts using the Boundless infrastructure. And anyone can create new types of agreements permissionlessly.
Give us an example.
Okay, maybe Alice needs proofs regularly for her dApp. She makes a deal with Charlie, a prover, to buy X compute cycles per week for the next 3 months at a fixed price. Alice gets budget certainty, Charlie gets predictable income.
Or a bigger protocol developer.
Yeah, maybe Pam needs super high reliability. She could buy agreements from multiple different provers, maybe spreading them out geographically, ensuring she always has proving capacity available, sort of like diversifying her compute supply chain.
Is there anything tricky about these agreements?
One key thing is data availability. The prover needs to make sure the requester can't just withhold the necessary input data and cause the prover to fail the agreement unfairly. So agreements often specify using public, permissionless data sources everyone can access.
Makes sense. And if people want to follow the development,
It's all happening in the open at beboundless.xyz, code, docs, everything.
all right. It definitely feels like Boundless is a major step towards making ZK proofs practical for scalable, trustless compute power for blockchains.
It really does. It's offering a potential path to a future where those scaling limits we always talk about are much less of a constraint.
It's fascinating, isn't it? You get more power by moving things off the chain,
Hmm.
but you maintain or even enhance the trust because of the math involved in the proofs.
Exactly. And for you listening, I know some of this sounds maybe very technical, almost like science fiction, but this is genuinely where the edge of the technology is moving.
So the big question then is, could something like Boundless be the thing that enables that elusive killer dApp, the one that brings blockchain mainstream?
It's certainly got the potential. If dApps can become as powerful, fast, and easy to use as the web apps we use every day, but keep that decentralized trust, that's a powerful combination.
And maybe most users won't even need to know how it works, right? They'll just experience, I don't know, super cheap cross-chain swaps or games that feel richer or logins that just work seamlessly, all backed by ZK proofs under the hood.
That's the ideal scenario. The complexity is abstracted away. It points towards blockchains evolving, maybe, from being just ledgers to being these universal verifiers at the center of a much larger computational ecosystem.
The world computer idea, but maybe more like a world verification network.
Something like that. It really unlocks a huge amount of creative potential, knowing you can verify almost any computation trustlessly.
It's exciting stuff. And hey, speaking of evolving, have you seen the Gberry thing on crypto Twitter?
Uh huh. Yeah, Gberry. It's funny how these little community things pop up. Maybe it's a sign of new growth, new possibilities blooming.
Well, lots to think about there. The implications of truly scalable, verifiable compute are pretty profound. Definitely encourages you to look deeper into Boundless and what this kind of tech might unlock next.